Hi students, this is Alex here. In this video, we are going to find the Fourier series for the given function f of x. As a first step, we are going to write formula for f of x, which is a0 by 2 plus summation n equal to 1 to infinity an cos n pi x by L plus summation n is equal to 1 to infinity bn sin n pi x by L. Here the value of 2L is 2. So L is 1. By using 1 here, we get f of x equal to a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x, because L is 1. Same way, the next term is summation n is equal to 1 to infinity bn sin n pi x by 1. So it is sin n pi x. Now, to find a0, our formula is 1 by L integral 0 to 2L f of x dx. And this is 1 by 1 integral 0 to 2. We substitute L as 1 and we have f of x dx. But f of x is made up of two parts. One is pi x from 0 to 1. Another is pi into 2 minus x from 1 to 2. So we are going to write the first part, that is from 0 to 1. It is pi x. And second one is 1 to 2 pi into 2 minus x dx. Now we integrate this. The first part is pi is a constant, x integration is x square by 2, and we have the limit from 0 to 1. And second term, pi we take out, 2 integration is 2x and x integration is x square by 2, and we have a limit from 1 to 2. So now when we use the upper limit, 1 square by 2 is 1 by 2, lower limit is 0, and here when I put 2 here, 2 to 4 minus 2 square by 2, when I put the lower limit, 2 minus 1 by 2, and here we can cancel this. So finally this part is pi by 2 and we have pi here, 4 minus 2 is 2, and after removing this bracket we get minus 2 plus 1 by 2. We can cancel this. So we left with only 1 by 2. So totally an is pi by 2 plus pi by 2. By adding this we get 2 pi by 2. We can cancel. So finally an is pi. So we got an. Now as the next part, we are going to find, this is a0, and next part we are going to find an. So an by formula, it is 1 by L integral 0 to 2L f of x cos n pi x by L dx. Since L is 1, we get 1 by 1 integral 0 to 2 f of x cos n pi x dx. Now we are going to split this into two parts. One is from 0 to 1 pi x into cos n pi x dx, and again 1 by 1 integral 1 to 2 pi into 2 minus x into cos n pi x dx. Here we are going to use Bernoulli's integral formula, integral uv dx, which is uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus dot dot dot. So here this part is u and this part is v. The same way this is u and this is v. So we can also take the pi outside. So now coming to an, we keep I outside, we take u as x. So as per the formula u v1, so x. Then v1 is the integration of this, which is sin n pi x by n pi minus u dash, which is 1. v2 integration of this, which is minus cos n pi x by n pi, and already there is one n pi in the denominator, so n pi whole square. And u double dash will be 0, so don't need to write that. So we put the limit 0 to 1 plus. Again, coming to the second part, we have pi outside. Then after that, u, which means actually it is a continuation of this. So 2 minus x into sin n pi x by n pi, then minus of derivative of this is minus 1, and integration of this is minus cos n pi x by n pi whole square, and limit is from 1 to 2. Now when I use the upper limit 1 in this place, this becomes 0 because sin n pi, and here when I use 1, cos n pi will become minus 1 whole power n. So let's write it neatly here. When I put 1, first term is 0, second term we have minus, and already there is a minus sign, so it will become plus minus 1 whole power n pi, minus 1 whole power n by n pi whole square. And when I put the lower limit, first term is 0 because x is there, and here this we can make it as plus, and no need to close this bracket. Let's write it neatly. Open a separate bracket for the lower limit. First term is 0, then cos 0 will become 1, so 1 by n pi whole square. Similarly, when I put 2 in place of this, this becomes 0, and when I put 2 here, cos 2n by will become 1. So first term is 0, and we can cancel these two. There is a minus sign. Cos 2n by is 1, so 1 by n pi whole square minus, when I put the lower limit 1, sin n pi is 0, and here there is a minus sign. Cos n pi is minus 1 whole power n by n pi whole square. Now we are going to rewrite this pi into. We have this, and when I take this minus inside, it will become plus. So 2 times of minus 1 whole power n by n pi whole square. Similarly, when I take this minus in here, this is minus and there is a minus here. So minus 2 by n pi whole square. So an is pi. We can take 2 out, and we can take n square pi square also out. We have minus 1 whole power n and minus 1. And at this stage, we can take n if n is odd. It means minus 1 whole power odd number becomes minus 1. So minus 1 minus 1 become minus 2. Already there is a 2 pi outside. So minus 4 pi by n square pi square. So we can cancel this. So minus 4 by n square pi. This is the value of an when it is odd, and if n is even, when it is an even, so this value minus 1 whole power even number becomes 1. So when this is 1, 1 minus 1 is 0. So an becomes 0. So we are going to use, when n is odd, this is the value of an. Now next part, we are going to find the value of bn. So by formula, Bn is 1 by L integral 0 to 2L f of x into sin n pi x by L dx. L is 1. So this is 1 by 1 integral 0 to 2 f of x into sin n pi x dx. And this we are going to split into two part. 1 by 1 integral 0 to 1 pi x is the first part, sin n pi x dx, plus again 1 by 1 integral 1 to 2 is our limit, and here it is pi into 2 minus x sin n pi x dx. So once again we are going to use Bernoulli's formula. We shall take this pi outside. This is our u and this is our v. Similarly, pi is outside. This is our u and this is our v. The Bernoulli's formula is uv dx is u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus dot dot dot. So here pi we keep outside. First is u, which is x. Then v1 is integration of sin n pi x, which is minus cos n pi x by n pi. Then minus u dash, which is 1. And integration of this will be minus sin n pi x by n pi whole square, 0 to 1. Then again for the second term it is 2 minus x into minus cos n pi x by n pi, then minus of minus 1 because this differentiation is minus 1, and minus cos n pi x by n pi integration is minus sin n pi x by n pi whole square. Now we have our limit from 1 to 2. So now when I use the upper limit, first term, when I put 1 here, we get cos n pi. So this is 1 and 2, there is a minus sign, and cos n pi is minus 1 whole power n by n pi, and sin n pi is 0. So second term won't be there, and minus, when I put lower limit, since it is x, it is 0, since it is sin, it is 0. So totally the lower limit is 0, plus pi into, when I put 2 here, 2 minus 2 is 0. When I put 2 here, sin 2 n pi is 0. So totally the upper limit value is 0. When I put 1 here, 2 minus 1 is 1, and this there is a minus 1, and cos n pi is minus 1 whole power n by n pi, and when I put 1 here, sin n pi is 0. So lower limit is totally 0. That is, the second part of the lower limit is totally 0. Now further rearranging this, actually we have pi open bracket, this is minus 1 into minus 1 whole power n by n pi, and this minus and this minus can cancel, and pi when I take common, we have left with only minus 1 whole power n by n pi. So finally these two terms are same with opposite sign, gets cancelled. So total Bn is 0. Now we substitute everything in our f of x. So f of x is equal to a0 by 2. The value of a0 which we got here is pi. So a0 by 2 means pi by 2 plus summation n is equal to 1 to infinity an. But an, we have a special case where it exists only for the odd. So we have to write when n is equal to odd, it is minus 4 by n square pi. Let's check again. Minus 4 by n square pi, and the remaining term is in the formula cos n pi x. So here cos n pi x. Then bn is 0. So last term will be 0. So f of x equal to pi by 2. You can take minus 4 by pi, which is a constant. Then summation n equal to odd till infinity. We have cos n pi x by n square. Suppose we can leave the answer like this, or we can change n as 2n minus 1. So 2n minus 1 is an odd term. So f of x becomes pi by 2 minus 4 by pi summation. Now we can write n is from 1 to infinity, and cos, in place of n we have to put 2n minus 1 into pi x by 2n minus 1 whole square. We can leave the answer like this or like this, or even we can go for expanding this series, that is f of x equal to pi by 2 minus 4 by pi open bracket, and continuously we have to place the odd number for this n. When I place 1, it is cos 1 pi x by 1 square. The next odd number is 3. So cos 3 pi x by 3 square. Next is 5. So cos 5 pi x by 5 square plus dot 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 till infinity. So we can leave the answer in any one of these form. All are equally valid.